right, so here we go. Let's see. It is January 11th. And we're looking at section 4-2, and this is going to be part A because we're dividing this in 2 days here. Okay, so we're going to start defining our various trig functions. We've got 6 of them: sine, cosine, tangent, cosecant, secant, and cotangent. There are 6 trig functions. You probably only knew about the first 3 from geometry: sine, cosine, tangent. Those are the 3 on your calculator, but there are 3 other ones. All right, now we're going to base them right now on a unit circle. So I want you to pictorially understand what we're going to be doing here. All right, so I'm going to say trig functions defined using a unit circle. And then we're going to put lots of information down here. I'm going to kind of draw out because I want you to see this from a pictorial standpoint, and then I also want you to be able to then have the 6 trig functions defined. All right, unit circle. We talked about this last week. A unit circle has a radius equal to 1 unit. All right, now, that's not going to be the only type of circle that we use this semester, because couldn't I draw a circle with radius 4 or circle with radius 10? All right, that radius can change in size depending on how I draw my circle. But right now, we're just going to focus on a radius of 1 for our unit circle. Okay, I'm going to draw a unit circle, and we'll always put that unit circle on that coordinate plane. All right, the best we can here. Okay, not a perfectly drawn circle, but not too bad. All right, if I know this is a unit circle, I know the radius is 1, so if I start at the origin and I go to the right, then I know this is the point 1, 0. Okay, now what I want to do is I'm going to think pictorially about a picture falling anywhere along this. Did I say a picture? I'm not talking straight. It's okay. It's the end of the day. I'm going to pick a point anywhere along this circle. All right, let's say I randomly pick a point here. All right, I'm going to call it P. What's the coordinates of that point? If I start at the origin, I would go to the right x, some x number, because it's along the x-axis. All right, and then I would go up some y value, right, because it's going up. So generically, any point along this circle is going to have an ordered pair of x, y. The x value and then the y value. All right, now if I draw another radius here, okay, and then that would be an angle in standard form, all right, because that initial side's along the x-axis, going counterclockwise around, that would be my theta. Okay, so depending on where that point is, all right, my theta changes, right? The size of the angle would change. If I would have picked a point over here, it would have been a bigger angle. If I would have picked a point down here in the 3rd quadrant, it would have been even bigger. Okay, so that's kind of what we got going on here. All right, now let's just define them. When I give you things to memorize, I'm probably going to write them in a certain way, in a certain order, for a reason, because it's going to help you memorize them. All right, so when I do the 6 trig functions for right now, a lot of times I'm going to give you sine first, I'm going to give you cosine second, and then I'm going to give you tangent third. All right, that's the 3 that you know from geometry. That's the 3 that's on your calculator. All right, say that again. Yeah, that's theta after all of them, and my thetas get kind of sloppy depending on my handwriting. Okay, that one's really crazy compared to that one. All right, now there are a total of 6. All right, so the other 3 that you are probably not familiar with are cosecant of theta, and then secant of theta, and then cotangent of theta. All right, so these to me are the traditional ones that you learn first. These, I just kind of refer to those as the cos, all right, because a lot of them, cosecant, secant, cotangent. All right, these 3 are not on your calculator, okay? Now, I'm going to define each of them based on this point, all right, something that we're going to want to write down and remember. In an ordered pair, the first coordinate represents the cosine of a number, All right, and the y coordinate represents the sine of the angle. Okay? In which case then, if I'm going to look at this ordered pair here, and I want the sine of theta, well, if my sine is my y coordinate, and this is a random point I'm picking here, then sine of theta is y. Cosine theta, it's the x coordinate because it's always the first one, so formula is x. All right, now from there, you just got to remember what tangent is. Tangent is going to be y over x. Now, when you go to memorize these, if they're listed in this order, okay, or you memorize them in that order, then really you only have to memorize these three, because cosecant, secant, and cotangent are the reciprocals of these. So y is the same thing as y over 1. If I take the reciprocal, it's 1 over y. If I take the reciprocal of x, it's 1 over x. And then if I take the reciprocal of tangent, I would flip that around. It would be x over y. Okay, that's your first set that you got to memorize. Okay, so you're going to memorize those. I'm not going to always write down the word memorize on every one of them, but that's going to be your first 6 from today. All right, now, why? Why am I giving this to you? It's because you're going to use these formulas when I give you a random point that is on a unit circle. You're going to use these formulas then to figure out what the sine of theta is, or what the sine of, or cosine of theta is, or the tangent of theta. All right, so moving forward, let's do an example. Okay, you've got these, you'll use these. And then somewhere on there, these are probably on that sheet somewhere, okay? They're probably on your reference sheet somewhere. All right. Let's say the directions say find all 6 trig functions given a point on a unit circle. Okay, so there's your directions. Find all 6 trig functions given a point on a unit circle. All right, and the key here is the fact that I'm telling you it's on a unit circle. Like I said, a little bit later on, all right, we're going to switch our circles up, and maybe it'll be a circle with radius of 2 or a circle with radius of 5. So it's not going to say a point on a unit circle. It'll say a point on a circle with radius 6. Okay? Now, let's say they give you then the point negative square root of 3 over 2 and a negative 1/2.
So this isn't going to be a nice.
Say that again?
So they're not going to give us like a nice and easy.
No, they're not going to give you nice, easy numbers. Nope. Because if you look at that reference sheet that I've given you, and if you look at all the different points all the way around and look at the ordered pairs, they're not nice numbers. They're square root of 2 over square root of 2. Or they're 1/2 square root of 3 over 2. All right, all the points on that unit circle look like this. Okay? Now, let's picture this. This is an ordered pair. It's negative, negative. If I start at the origin and I plot negative and negative, what quadrant am I in? Negative, negative puts you in the third coordinate, or third quadrant. Man, having a really bad day. Okay, so I'm just going to sketch this. All right, let's visualize it. Here's our unit circle. I know it's a unit circle because it has a radius of 1. It told me I did. All right, we said that this point is going to be somewhere in this third quadrant, so I'm just going to randomly pick a spot right there. Doesn't have to be accurate, but that point there is negative square root of 3 over 2, negative 1/2. All right, now, did it form an angle? It does form an angle. In standard position, going counterclockwise around, there's my theta. Okay, there's my theta. Now, I want to find all 6 trig values. So I want to find the sine of theta. I want to find the cosine of theta. And I want to find the tangent of theta. All right, now I want to find all 6 of them. I'm going to start with those 3. Why? Because the other 3 are the reciprocals. And if I really trust myself, then I can just find 3 answers and then take the reciprocal. All right, now, what did we say about the ordered pair? All right, here's my ordered pair. Where can I write this? Ordered pair is xy, right? And then the first coordinate is that sine or cosine? First coordinate is cosine. And then second one is sine. Okay, so that's going to make it really, really easy, right? Because if I want the sine of theta, I'm going to look at my second coordinate and I'm going to write down -1/2. Because that's my y coordinate. Sine is y. That one was easy. All right, cosine, all right, is the first coordinate. I want to find cosine of this angle, cosine of theta. So I'm going to come down. I'm going to look at the point. This is my x. All right, so -√3/2. All right, really fast. Okay, now, what was the formula for tangent? Y over x. Okay, the formula was y over x. Okay, this is my x coordinate. This is my y coordinate. Okay, so can I do the math? Can I put a -1/2 over a -√3/2? Yes, I can. It's nasty. All right, that's my y value on top. That's my x value on the bottom. Is that a complex rational expression? Yes. Did we learn how to simplify those in first semester? Yes. Multiply through by the least common denominator. Remember that? The least common denominator is 2 because I got 2 denominator here. I have a 2 denominator here. So multiply by 2, multiply by 2. That means 2's cross off, 2's cross off. All right, so then I have -1 over a -√3, but a negative divided by a negative is a positive, so a 1 over √3. Okay, now go back to first 9 weeks when we were reviewing our radicals. Did we rationalize things that had a radical in the bottom? Yes, we did. So I need to multiply this by √3 over √3. Which makes my numerator √3. What's √3 times √3 on the bottom? Just a plain 3. √9, which is 3. So then I finally have an answer. Did I have to go through some math to get there? Yes, I did. All right, so no, I'm not going to ask specific questions from first semester. Do you still need the skills that we learned in first semester? Yes. Joe?
Will they ask us for the √3 over 3? Is that going to be our answer, or will they ask for the big complicated one that I don't really like?
The big this one?
Yeah.
No, they don't want this. You have to do this to get to here, but they want you to write this.
Okay.
Okay. All right. Now, if you trust yourself and you think you did not make any mistakes, you could just take the reciprocal, take the reciprocal, take the reciprocal. All right? Or I could use 1 over y, I could use 1 over x, I could use x over y, I could use the formulas. All right? Doesn't make any difference. Can I take the reciprocal of this really easy? That's going to be -2, right? So no work, not a whole lot of thought there. That's faster than trying to do 1 over y. All right, can I do the reciprocal here? Yes, I can flip it around. All right, it's still going to be faster if I go -2 over √3. Am I allowed to leave it like that? No, because we rationalize that denominator. So rationalize it by multiplying by √3 over √3, which then is going to give us a -2 √3 over 3. Okay, so that's still better than trying to use the actual formula. Just take the reciprocal. All right, now for the cotangent, reciprocal of this one, put the 3 on the top, √3 on the bottom, and then I don't get to leave it like that because we want to rationalize that denominator. So multiply by √3 on both of those will give us 3 over √3 all over 3. Oh, but now what can I do? Cancel out the 3's. Okay, so that's going to make that one just a nice little √3. And we did all of that. And if I just take it from this and I don't actually look at a unit circle or anything, I don't know how many degrees theta is. All right, but this is on the unit circle. You could find it on the unit circle. You could tell me how many degrees this is. All right, but that's not what the question is wanting. They're wanting a random point on a unit circle. Can you do all 6 trig values? So that's how you're going to use those formulas. All right, good on the first set.